All right, so the majority of the feedback that I received on yesterday's lesson, with the wrap up of reactions, it seemed like most people were in the majority of ready to move on to new material. So we're going to take this little pieces at a time. So what we would normally cover in one day is going to take us a couple of days because I want to make sure that you're understanding it before I give you a assignment to see your understanding. So the first thing that you are definitely going to need is your calculator. So hopefully you have one. If you don't, you can access the calculator on your phone. If you have issues with trying to track down a calculator or finding one that works for you, let me know and I will do my best to see what I can do to help you. So with our calculator coming back, that means we're going to be doing some math. And so we are going to be doing conversions again. So I just threw two really easy conversion problems just to give you a reminder of how we set these up because it's been a little while. So these two are working with inches and feet. And if you remember back to when I taught you conversions, you need a conversion factor. And so it's always a relationship between those two units of measurement. So you know that 1 foot always contains 12 inches. That's your conversion factor. And if you remember, the wording I used is that if you have a given or not. So in this first problem, it asks how many feet are in 46 inches. Well, our given, remember, is two components, the value with the unit. So we have 46 inches. They want to know how many feet we have. So we can go ahead and set up our space to do our conversion. If you remember, the unit you have is what you are going to put in the bottom, because again, what you're doing is dividing. If you divide something by itself, it cancels. So 12 inches should be your bottom unit. 1 foot should go in the top. Again, we can see we have inches top, inches in the bottom. I like to put a slash through them to eliminate them. So mathematically speaking, this first example, it's telling you to take 46 times 1 divided by 12. You don't really need to do the times 1 step, so 46 divided by 12. If you run that through on your calculator, if you remember, 2 decimal places is all I'm asking for. So we're going to go with 3.83 feet for our answer here. In the other review conversion, we have 15 feet for our given, and they want to know how many inches we have. So we're working with the same information. However, we're using our conversion factor differently here because our given unit is feet. So 1 foot would need to go in the bottom in this example, the 12 inches in the top. Mathematically speaking, all we need to do then is multiply it out. If we take 15 times 12, we get 180 inches. Okay, so that was our quick blast from the past review on conversions. Moving forward, what we're going to talk about today is calculating with the mole. And so we're not talking about the furry little animal. We're not talking about a mole on the person's skin. We're talking about a counting unit. And so one thing we started out with at the beginning of the year is talking about atoms, and we've introduced molecules since we did covalent bonding. And so we have a way that we can count those. So if we have a sample of something, we can count how many atoms it contains or how many molecules it contains. And that's using a conversion called the mole. It's really no different than the inches to feet, or in my example here that there's 12 eggs in a dozen. It's just a counting value. And the more we work with it, the more it's going to start to mean something. So let's give it a second. There we go. It synced up. So the value that we use to do these conversions is what's called Avogadro's number or Avogadro's constant. I would maybe, even as you go through resources, especially starting on Thursday, most likely we're going to need a periodic table. I would go ahead and write this conversion factor on there. So the conversion factor for Avogadro's constant is this value right here. So depending on if you're working with a pure element like iron or lithium or carbon, we would count that using atoms because it's an element and elements are built from atoms. If we're talking about carbon dioxide or sugar or water, it's a compound that's held together. Again, it has more than one type of element in it. We would count that using molecules. And so 1 mole contains a very, very large value, 6.022 times 10 to the 23rd. And later on this week, I'll have you watch a video that kind of helps explain how large that number really is. And so like we said, 12 eggs is to a dozen. 1 mole is 6.022 times 10 to the 23rd atoms or molecules. So how we can write that conversion factor. So we can say that 1 mole, and chemists are lazy, so mole, not that it's a really long word to begin with, but we can abbreviate it. And so we show mole as MOL, and we leave off the E. That's equivalent to 6.022 times 10 to the 23rd atoms. The other way that you can express this conversion factor is to reverse that. So you can say 6.022 times 10 to the 23rd atoms is to 1 mole. And so I said your unit here with the 6.022 can kind of have two outcomes depending on what you're counting. Again, it's a matter of, are you counting an element or are you counting a compound? So this would be used if you're working with something that's an element. The other option is you could say that 1 mole, and actually let me switch my pen color over, is to 6.022 times 10 to the 23rd. But instead of atoms, if you're counting something that's a compound, and specifically a compound with covalent bonds, we call them molecules. And we can abbreviate them as MQules. Because again, we as chemists are lazy and we like to save ourselves writing. So the conversion factor between the two is the same. What I'm trying to get at is you can use this conversion factor for both an element or a molecule, which is different in that it is a compound. It contains 2 or more elements. Okay? So the remainder of the notes, we're going to do 4 examples working through how to use this information to solve the problem based on your given. So this first example asks how many atoms are in 4 moles of Fe. So you have to, again, break that problem down, no different than we did inches and feet. The process is all the same. So our given is this 4 moles of Fe. So I can go ahead and write that in. And what I need to do is I'm looking for atoms. So I know that, again, 1 mole is equal to 6.022 times 10 to the 23rd. And that can be either atoms or my molecules. Okay, so we have 4 moles. So based on the unit you have, that's the unit that's going to go in the bottom. So that's going to be the 1 mole portion of my conversion factor. The top piece is going to be the constant 6.022 times 10 to the 23rd. And this is going to be atoms because it's only iron. Now, it's been a little while since we've put this in calculators. Remember, you have that EE function. We have a couple of options if you're needing help. If you don't remember how to type this in, if you can take a picture of your calculator, send it to me in Google Hangouts or as an email, I can reply back on how to type it into your calculator if you need help. Again, you definitely need a scientific calculator for this. So you can try looking on your app store and seeing what you can find out there for a scientific calculator. And again, if you're struggling, let me know and I can help you out. So mathematically speaking, we're going to take 4.00 times that 6.022. That's when I would do my second EE to get that E on my screen, and then I would put in just 23rd. Okay? And so when I did that, I got 2.41 times 10 to the 23rd atoms. And I like to label it with what it is, and I forgot to mention that. With where we're heading, it's good to start including not only the unit, like moles or atoms, but of what? Of what material are we talking about? And this is specifically iron. And like I said, this is just a good habit to get into. In example B, it asks how many molecules are present in 1.75 moles of carbon dioxide. So same idea, I have my given here. And the difference is this particular problem is looking for molecules versus atoms. The reason why is this is CO2, carbon dioxide. So we're now looking at a compound versus just a pure element. Write out your given, 1.75 moles of CO2. Again, I'm going to include the what. So in this problem, I'm going from moles to molecules. So that's where it's important to distinguish your units so you can separate the fact that moles and molecules are not the same thing. So molecules is a smaller piece of a mole. So if we had, say, water, if we zoomed in on water, we'd see individual molecules of hydrogens and oxygens bonded together. Those are molecules. Them together can represent a quantity such as a mole. What we are doing in terms of setup is going to be the same. So I can put 1 mole in the bottom, just like example A, Avogadro's constant in the top. The only thing that's different is that we're going to have a unit of molecules or molecules up here versus just atoms. So the same idea is you're going to run this through on your calculator and multiply. Now, if you didn't get the right answer, the same answer as I did in A, I'm going to write this out on how I should type this in. So you should just type in 1.75 times 6.022 E 23rd. Remember that E represents times 10. If you put in 6.022 E times 10 to the 23rd, you're going to end up with an extra power in there and your number is going to be off. So again, what that does is it helps eliminate you putting in that times 10. So if you are having any calculator issues at all, reach out to me. I will do my best to help you. So again, rounding this off to 2 decimals, I get 1.05 times 10 to the 24th. If I eliminate units here, moles cancels out, so I have a unit of molecules or molecules. And again, my what is carbon dioxide. 2 more examples. We have C and D to take a look at. So in example C, it asks how many moles are in 3.01 times 10 to the 24th molecules of carbon dioxide. So my given is starting out here as molecules, and now we're going to go to moles. So I can go ahead and write in my value, 3.01 times 10 to the 24th molecules of CO2. Again, notice I put a unit and my what. So how this problem is different than the previous examples is that we are still using the same conversion factor. The only thing that's changed is, much like my inches to feet examples at the beginning, is that 6.022 is now going to be in the bottom. It tells me that it's molecules, so I know that this needs to be labeled molecules, not atoms, and that I can see I'm working with a compound. Up top will be the 1 mole. So in this case, we are now going to be dividing versus multiplying. So for this particular example, I would type into my calculator 3.01. I would get my E, so second EE for most of you. Again, if you have something else, let me know and I can help you. 24. I'd hit my divide button. 6.022 E23. When I work that out and look for an answer, I get an answer of 5 moles. And what is it? Carbon dioxide. Last example then. So we have 1.50 times 10 to the 24th atoms of helium. So we're back to working with an element. So that means we're now counting as atoms versus molecules. it wants to know molecules. So, or excuse me, not molecules, but moles. So when I go to set this up, I need my atoms to cancel. So Avogadro's constant needs to go in the bottom. And 1 mole will be in the top. Again, like the previous example, mathematically what you're going to do to solve this is divide it out. So take 1.5 times 10 to the 24th, divide by Avogadro's constant, and you get 2.49 moles of helium. So again, if you are stuck, confused, you have to reach out to me. That's the only way if I'm going to know that you need help. It's a little bit hard because in class, you can raise your hand, you can come seek me out. Unless you say something, I unfortunately am kind of a little bit at a loss in terms of if you are needing help. So what is left in the notes is these 3 practice problems. I want you to take a second, try these out on your own, set them up, come up with an answer, and then we'll touch base on Wednesday and we'll see how we did with these 3 problems. So again, send me a Google Hangout message, send me an email if there's any questions, any concerns that you may have.